Today's video is about using addition to help with subtraction. It's recommended that you revisit the video on number bonds and fact families before watching this new one. In a previous video, we learned about number bonds. Number bonds show us how numbers are connected or related to one another. They help us create fact families. As an example, if we have 5 in one part and 5 in another part, and we put the parts together, we make a whole group of 10. We learned how to show this with addition and how to show the opposite. The whole group, taking away one of the parts, leaves us with the other part. We learned how to create fact families using number bonds. Today we're going to do the opposite order. I'm going to teach you how to look at either an addition or subtraction equation and put the numbers from that equation into a number bond. If we look at this equation, 2 plus 3 equals 5, can you determine which numbers are the parts and which number is the whole group? Think part plus part equals whole group. Part plus part equals whole group. Can you put the numbers in the correct places? 2 is one of the parts, 3 is the other part, and when you put them together, you make the whole group. Many of you might find addition easier than subtraction. It's easy to remember part plus part equals whole group. But what if I were to show you a subtraction equation? Six take away 4 equals 2. Could you figure out which number is the whole group and which numbers are the parts? When we look at a subtraction equation, we always start with the whole group. Whole group, take away one of the parts, equals the other part. Whole group, take away one of the parts, equals the other part. Let's try another example where I give you a subtraction equation and you fill the numbers in on the number bond. 7 take away 5 equals 2. Whole group, take away one of the parts, equals the other part. You know the whole group, you know one of the parts, and you know the other part. This is all well and good when you're given the entire equation, but what if you are not given the complete equation? How can you use a number bond to help you? Here's a subtraction equation, but it's incomplete. It's unfinished. 9 take away 8, but the answer is not given. Let's fill in the numbers that we do know in a number bond. Remember, with subtraction, we always start with the whole group, and we take away one of the parts. The answer will be the other part. We don't know what the answer is. We can fill in the whole group. We know one of the parts, but we don't know the other part. So let's use addition to help us. Using addition can help us find the answer in subtraction equations. You might have an easier time thinking about part plus part equals whole group, and that can help you determine the missing number. Part plus part equals the whole group. 8 plus something equals 9. If you imagine a number line, you might readily be able to tell that you only need to jump one more time to get to the number 9. You only need to get bigger by 1. So if 8 and 1 go together then to make 9, The opposite must be true for subtraction. Whole group, take away one of the parts, equals the other part. Now we know what the other part is. We used addition to help us determine the missing part. That helped us solve the subtraction equation. Let's try another example. 7 take away 4 equals, we're not sure. Let's fill in the numbers given in a number bond. In subtraction, we always do whole group, take away one of the parts, equals the other part. We know the whole group. We know one of the parts. We do not know the other part. Let's use addition to help us. Part plus part equals whole group. I'm at 4. How much bigger do I need to get in order to land on 7? 5, 6, 7. Some of you might be able to do this in your head. You might think to yourself, I know 4 plus 4 is 8, so therefore one smaller, 4 plus 3, will be 7. For many, addition is easier than subtraction, so thinking about part plus part might help you figure out the missing number and solve a subtraction equation. Addition and subtraction equations are not always written horizontally. They don't always present themselves going across a page. Sometimes we write them up and down. Here's an example. 10 take away 8 equals, we're not sure. This equation is shown vertically, not horizontally. But sometimes this is nice because we can think about addition by going the opposite direction. We know in subtraction we have our whole group and we take away one of the parts and the answer will be the other part. That means I can think about this backwards. Part plus part equals whole group. If this is my whole group, I can think about what goes together to make that whole group. You might be thinking about friends of 10 and quickly be able to figure out that the missing number is 2. If that's hard for you, try drawing a number bond. We knew the whole group was 10, and we also knew that one of the parts was 8, and we thought about what goes with 8 to make 10. In other words, instead of thinking 10 take away 8 equals 2, we went backwards and we thought about 2 plus 8 equals 10. When you stack your equations up and down or vertically, you can think about addition for subtraction. Let's do a few more practice questions. 8 take away 4. This is a subtraction question. We start with the whole group, we take away one of the parts, and the answer will be the other part. You could draw a number bond. We have the whole group, and we're taking away one of the parts. When you see it shown in this way, you might quickly be able to figure out the missing part, because you know doubles, 4 and 4, go together to make 8. But try and do it without the number bond. Try and think about addition, going backwards. So instead of reading the question 8 take away 4 equals the missing part, read it this direction. Part with this part equals the whole group. Part plus part equals whole group. You can think about how 4 and 4 go together to make the whole group. Try this next one. 18 take away 17. In the past, we learned a subtraction strategy where we counted backwards on our fingers. This would be very difficult to do. We don't have 17 fingers, and keeping track, counting backwards 17 times, would be very difficult. So in this case, thinking about addition to help us with subtraction might be the best strategy. we know that this is our whole group. In subtraction, we start with the whole group. We're taking away one of the parts, and the answer will be the other part. If you think about addition, you can read the question the opposite direction. This part goes together with the other part to make 18. You might quickly know that one more after 17 gives you 18.